This example comes out of section 8.1, Understanding Logarithm. In this first part of the example, we're just asked to evaluate, meaning find the answer of these logs. Some of them you'd be able to punch in one step quickly on a calculator, others not quite as direct. But the first one, if we say that this answer is equal to n, remind ourselves that this means that 8 to the n equals 64. Many of you will be able to say, oh well, n must be 2. You could say 8 to the n equals 8 to the 2, so n equals 2. But the answer to that logarithm is 2. If I try the same thing for the next one, again letting n or x or some unknown be the value here. If this is n, then 9 to the n equals 1, which means we have an answer of 0, because the only exponent that's going to give you an answer of 1 is an exponent of 0. Now, log 0.01, notice there's no base written there. What that means is that it's base 10. Log base 10 of 0.01 means that 10 to the exponent something is equal to 0.01. And the answer to that is equal to 2. So 10 to the, let's call it x, equals 0.01. And you find that the x is equal to negative 2. The next one, it's a power of 3 question. Again, if I let it equal to n, I've got 3 to the n equals the square root of 27. This one might take a tiny bit more work for you, but if you've got 3 to the n equals the square root of 3 cubed, which is 3 to the 3 over 2. So n equals 3 over 2. The answer to this logarithm is 3 over 2. Finally, the last one, actually maybe the easiest one, because it's base 10, you could just punch in log of 1,000,000 into your calculator. Again, if I call it n, the answer I've said 10 to the n equals 1,000,000, and you find that the n equals 6, so the answer to that logarithm would have to be 6.